We have a list that is already sorted in increasing order and a target sum here 9. We want two numbers in the list that add up to exactly the target, and we want their positions. 2 and 7 add to 9, so the answer is indices 0 and 1. The sorted order is the gift that makes this fast. Because the list is sorted, we can start with one finger on the smallest number and one on the largest and look at their sum. If the sum is too small, the only way to grow it is to move the left finger rightward to a bigger value. If the sum is too big, we move the right finger leftward to a smaller value. Each move rules out a number for good, so the two fingers squeeze toward each other until they meet the target. No sorting extra, no nested loops. We put left at the first index and right at the last. While they have not crossed, we add the two values. If the total matches the target, we return both positions. If the total is too small, we step left forward to a larger value. If it is too big, we step right backward to a smaller value. If the fingers meet with no match, we return -1, -1. Let's build it in the live editor, one block at a time. We place one pointer at the smallest number on the left and one at the largest on the right. While the pointers have not crossed, we add the two values, and if they hit the target, we return both positions. If the total is too small, we move left up. If too big, we move right down. And if they meet with no match, we return -1s. Now, let's test it and hit run. There it is. 2 and 7 make 9 at indices 0 and 1. The second list finds 4 and 5, and when no pair works, we return -1, -1. The sorted order is what lets the two pointers do this in one pass. The shape is this. Start left at the beginning and right at the end. While left is before right, check their sum. If it equals the target, return both positions. If it is too small, move left up. If it is too big, move right down. If they cross with no match, return -1s. The two pointers only ever move toward each other, so together they take at most n steps before meeting, giving order n time. We keep just two indices and a running sum, so the space is order 1. The plain double loop would have been order n squared, which the sorted order lets us beat. 3 reminders. This only works because the list is sorted, so if it is not, sort it first or use a different method. Keep the loop while left is strictly before right, so you never add a number to itself. And decide in advance what to return when there is no valid pair. Here we chose -1 and -1.